Hey everyone, this is Finn Scown,
And I'm Aaron Rockwitz.
and we're here to talk to you a little bit about AR development and just some of the brief things to consider while making 2D and 3D assets for augmented reality.
So, first off, before we really get into all of our tips, we wanted to explain just some details about what exactly augmented reality or AR is. AR is a form of media that is superimposed images and audio over real world camera footage. The most obvious example I can think of that most people would be familiar with is Pokemon Go. It is an augmented reality or AR mobile game. You can see here that Pikachu isn't in the real world, but by holding your phone up, you can see him as if he were in the real world, and he will stay in the same position so you can move all around to look at him. AR utilizes the cameras on mobile devices, obviously, but how does it really work? A lot of modern mobile phones have really sophisticated spatial detection technology built into them already, and AR basically takes advantage of all of that. It utilizes spatial detection as well as markers and anchors to help assets, which are basically 3D objects or 2D objects that you've put into digital space. Markers and anchors will help those things stay in the same location so that multiple people using an augmented reality app can look at an AR scene from multiple different perspectives at the same time. AR also utilizes geolocation in some applications, and this can be more or less efficient depending on your device than the typical anchor and marker-based AR technology. If your device's GPS doesn't work very good, or it's just a little bit off, sometimes geolocation AR apps can just be slightly off as well. That's why markers tend to be a little bit better and a little bit more reliable. How is AR being used right now? So obviously, we're mostly familiar with AR being used in mobile games. That's most of what consumer level AR technology is. However, AR has been on the scene in the business side for a lot longer than we've been seeing it on the commercial side. One cool project that we did here at Boise State University was the ARSIS project, where a team of students actually got to work with staff and team members of NASA to help them create an augmented reality communication application and demo. This is just some of their early prototypes, what it was looking like, but this project was aimed at enhancing communication between astronauts that have augmented reality built into their helmets and space stations down on the ground. AR can also be used for medical training and any other kind of training, really. This is a cool AR app for medical students that lets them see different parts of the human body all working together at the same time. They can move them around. They can see how they work together, how they work individually. It's a little bit more hands-on of an experience. AR also works really well for retail and equipment maintenance. Harley has been using this augmented reality app to let customers check out the new bike models as well as different modifications that you can choose to make sure that you can really get a full picture of the kind of bike options you have before you see them in person. AR also works really well for interior design and furniture applications that will let you see the furniture in your home before you purchase it to see if it'll go with your existing decor. Another application that we developed here at Boise State University is the Bronco Tours application, which utilizes AR as sort of a selling point to make it more interesting. As students explore Boise State's campus, they can check out various AR artifacts that we've placed around to make the experience more interesting for them. One field in particular that AR really shines in is education. AR is a really highly engaging and flexible medium. It promotes physical interaction with the learning material, so students can really not just sit and experience their learning material idly, reading a screen or reading a textbook, but they can actually get up and move around and get down on the ground and really interact with their learning material like they never have been able to before. However, AR can still be used for stationary learning for students that aren't able to move that way. Another cool thing about AR is that it promotes group learning in a really cool way. Multiple people can experience AR from just one device as a group, or they can have several devices and all experience the same application in different ways. AR is a lot more fun than just reading a traditional textbook. If my textbooks had been able to have something like this, I definitely would have been more interested. Some of the ways that we've been using AR at Boise State University for education in particular started off with ABC Stories. It's an augmented reality handwriting application. And really, AR for this application was helpful because handwriting is a really tedious thing to learn. And so by making it more engaging, we were able to have students practice those handwriting habits early on, and they can see a story play out before them. And as they write, they can see things move and change and build up those skills in a way that's not so tedious and not so exciting. Hygiene Hullabaloo was another AR app that we developed here at Boise State. And this one is particularly interesting because it focuses on hygiene and developing good personal hygiene habits, which again can be difficult to internalize for young children that really need to get those habits learned early on. You can see here that they reinforce these healthy habits through really fun gameplay. And that's what a lot of these apps really do too. AR is just a really particularly engaging form for these apps. We also created an application called Animotions Therapy. This one's another AR app that kind of like Snapchat filters or Animojis. It overlays cartoon characters that match your face as it's moving in real time. And this was designed to help children and others that struggle with emotional recognition so they can start building up those healthy habits through gameplay that's highly engaging.
So what devices support AR anyway? Today, almost all modern mobile phones are starting to be able to run AR apps. It requires either iOS 8 or newer or Android 4.0 or newer. Here are some examples of brands with devices that support AR Core and AR Kit development. Google, Apple, Asus, General Mobile, Nokia, HTC, LG, and Motorola. And most of these are going to be phones or tablets because augmented reality is primarily for mobile devices. Here are some AR-specific devices that exist as well, like Microsoft HoloLens. We've got multiple versions of the HoloLens 2, including an industrial edition and one with a built-in hard hat, the Trimble XR10. And that just makes it so that people who are working on site are able to use augmented reality in a safe way. We also got the more well-known Google Glass, Snap Spectacles AR, Vuzix Blade Upgraded, and Magic Leap 1 that are all a lot lesser known AR devices.
Here's some problems with the way our current digital space is set up. It can be very isolating. Whenever we use social media these days, it often feels like it's you against the world, you putting on your best face to show the whole world that everything about you is awesome and great and nothing to worry about. That can be a pretty isolating culture when it's gotten to the point that it has. Current social media are also prone to echo chambers, which in and of themselves are not necessarily a problem. All an echo chamber is a group of people all talking about the same thing, which when they're talking about things like sports or memes isn't really a big deal. But when you start talking about controversial issues in politics, echo chambers can start producing some pretty toxic cultures. Experiences through a screen alone are also not very engaging anymore. With all the technology we have available to us, a screen can really feel restricting, which AR can definitely help with.
Here's how augmented reality can help with those issues. We can start creating AR-based community experiences to encourage healthier digital socialization. Instead of just seeing it on a screen, users have somewhere to go together. And AR does exactly what the name suggests. It augments our reality. It doesn't replace reality, it just adds to it. And it doesn't contribute to wanting to escape from reality, as much as virtual reality might. So how do developers create AR applications?
One of the tools that are used for augmented reality development is Google AR Core. It's used for developing mobile AR apps for Android-supported devices. AR Core provides simple yet powerful tools for creating AR experiences and includes features like cloud anchors, which are persistent, multi-user, cross-platform AR experiences that can be utilized with both Android and iOS devices. They also include recording and playback, which accelerates developer workflows and unlocks new use cases with pre-recorded MP4s. AR Core also includes depth, which adds realism through object occlusion, immersion, and interaction. You can even do object and scene reconstruction with AR Core. Furthermore, it also includes environmental HDR. This is a lighting extension from the real world into virtual objects to make digital objects appear like they're actually part of a real-world scene.
For developing for Apple products, you use Apple AR Kit. This is used for developing any mobile AR apps for any Apple devices. It combines device motion tracking, camera scene capture, advanced scene processing, and display conveniences to simplify the task of building an AR experience. You can create many kinds of AR experiences with these technologies using the front or rear camera of an iOS device.
The software that is used to create AR experiences for Apple products is called Xcode. The Xcode program and developer tools include everything you need to create apps for iOS, iPadOS, macOS, tvOS, and even watchOS. ARKit is natively integrated into Xcode. It's incredibly valuable to learn Xcode as nearly all Apple products support augmented reality, and Apple is continuously developing improvements to ARKit. Another software that's used to create AR experiences is the Unreal Engine. It has native integration with the most popular platforms, including the HoloLens 2, the Magic Leap, Windows Mixed Reality, ARKit, and AR Core. Another software that's used to create AR experiences is Unity. Unity's AR Foundation allows you to work with augmented reality platforms in a multi-platform way within Unity itself. This package, AR Foundation, presents an interface for Unity developers to use, but doesn't implement any AR features on its own. To use AR Foundation, you also need to download and install separate packages for each of the target platforms officially supported by Unity. AR Core XR for Android, ARKit XR for iOS, Magic Leap XR for Magic Leap, and Windows XR for HoloLens. Here's some tips on how you might go about creating 3D assets for an augmented reality app.
Here are some things to consider. What's the size of the model? Is the model large or is it small? What's the distance the player is going to be from the model? Is the model far away or is it close? Is our player going to be able to walk up to the 3D model or is it in a fixed location that the player can't walk close to? What perspective is the player going to be able to view the model in? Can the player look above the model, behind it, below it? Does the object need all sides to be modeled, or are we only going to be seeing it from one side? All this helps us determine the detail and complexity needed from the models and their textures. Another big important thing to consider is efficiency and performance. This is pretty much always going to be your biggest consideration for any form of mobile development. Think about the equipment your app will be running on. Phones and other mobile devices can only do so much. With AR development, this is particularly important because the technology is already performance heavy. Stick to low poly models. Avoid creating models with excessive faces. Utilize simple materials over image textures when possible. Textures with resolutions greater than 2K can seriously slow things down.
ABC Stories, one of the apps that we developed here at Boise State University, is a good example of this. For Chapter 1's environment in the app, I created several low poly models with simple image textures and simple materials. All of this can load into the scene really seamlessly and quickly. However, we had to make some serious adjustments for Chapter 10's environment in the app because it included a lot of 3D models with really high resolution textures. So while in Chapter 1, I was using mostly simple materials and image textures, the instruments in Chapter 10 used textures that were at least twice that size. So we had to reduce the resolution on those in order to get the scene to load seamlessly. So basically, AR development is really friendly to beginner level 3D modeling techniques, which are going to be low poly models with simple textures. That's going to perform the best. Now we'll discuss some of the logistics of creating 2D assets for AR apps. Just like with 3D modeling, you're pretty much thinking about the same things. How close will the user be to the image or the animation that you're making? The closer the user is going to be to an image or an animation, generally the more you're going to want to increase resolution. The further away, you can decrease resolution. For those that don't know what resolution is, let me explain. Inside of an art program, you can change the dimensions of your canvas. You can change it to pixels or inches or any other kind of measurement tool that's native to the program. And different mobile devices like phones or tablets, and specific versions of each will all have their own dimensions on their screens that are optimal. So you'll want to check which device you're developing for to make sure that all of the things you create look good on that size of a canvas. Resolution specifically has to do with how something will look when it's scaled up or down. So here you can see I've created several cubes that are different sizes, and this is their 100% size here, 128 by 128, 64 by 64, and then 32 by 32. You can see that as we scale these things up, the higher resolution one is going to look pretty much the same, and the two lower resolution ones start to look a little bit grainier the more they're scaled up. So that's just something that you'll want to keep in mind. With images in particular, they can typically handle higher resolution. However, animations for AR need to have as small of a resolution as possible, as well as the lowest frame per second as possible. Animations are where you're really going to want to optimize and make sure that they are as small as you can make them. Furthermore, you got to consider which direction your 2D asset is going to be facing. There's a couple of different ways you can go about this, one of which is called billboarding. This is a technique where you can take a 2D object and make sure that no matter where the camera is pointed, it's always going to be facing toward the camera. In this case, wherever the user would be pointing their phone. They would see that 2D object as if it were right in front of them. However, another way that you could do that is having persistence, where the 2D plane would only be facing one direction at a time. Here are a couple of different ways that that might look. Each program will tend to automatically do one or the other when placing 2D objects, so you'll want to make sure you know what your program is going to do and whether or not you need to change it. This first example is called backface culling, and that's where the program is only going to be showing you what's in front and what's on the camera. And if you were to go behind, you wouldn't see anything on the 2D plane. It would be invisible. Another way that a 2D plane might look natively is it'll just flip when you look behind it. So from the front, it'll look one way, and then it'll just flip vertically the other way. 2D has limited perspective. You won't be able to see above and around the asset, only a single side at a time, and sometimes that's what you'd want. For example, like the billboarding effects. Particle effects like explosions and confetti, those are some examples of 2D particle effects that you typically want billboarded to the user's view. Another way to use 2D objects is actually in combination with 3D. Here you can see billboarding is not something that the user would want, because seeing this coin from this angle, you'd want the glow to be around it no matter what angle you're looking at it from. But the way the billboarding works on this 2D plane is that it cuts into the coin itself. So here's where billboarding would not be helpful. Another way that you could use billboarding or lack thereof is to hide a 2D puzzle element in your app that can only be seen from a specific angle. Although Finn's going to go into this more in just a moment, I do want to mention that most 2D elements in your augmented reality app should be for the app's user interface, or its UI. The truth of the matter is with 2D elements in an augmented reality app is that sometimes 3D is just going to work better than 2D. AR's capabilities are more fully realized with 3D assets. That's really what makes it exciting. Bringing 3D elements into our 3D world allows you to walk around them as if they were really in our world. And you can't really do that with 2D assets, with billboarding or when they're just standing in place. They look unnatural. However, 2D elements can certainly help make a 3D scene more exciting.
Now we're going to talk a little bit about designing a user interface for AR. Here's a brief reminder of what a user interface is. A user interface is everything graphically the player can see and interact with on any software application. UI design varies depending on the needs and platform of the application. Things to consider while designing for AR. Will the buttons be in the world space or on the screen/camera view? AR applications typically benefit from simple and easy to read UI because it's going to be on such small of a screen. Here are some of the different examples of user interface. GUI is interacting with data through graphic and visual indicators. For example, pressing an X to cancel something. Here's some examples of what that looks like. And here, when we're looking at this Sims 4 screen, we're not talking about all of this right here. We are particularly talking about right here with the time controls and the different icons that are represented. And here's an example of a checkmark button on an AR app. A HUD, or a heads-up display, is interacting with data layered over a fixed transparent display. Here are some examples of different HUDs in video games. VUI, voice user interface, is interacting with data through voice or speech. For example, when you ask Siri to set an alarm on your iPad. Here are some examples of times that we use that. PlayStation 4 has voice-activated commands. Any smart home Amazon product with Alexa, and any Google smart home device. And we're also developing a lot of assisted reality technology and we're also developing a lot of assisted reality technology where people can use AR with their voice on the worksite. A future user interface, or FUI, is a future-facing interpretation of interacting with data. For example, Iron Man visuals when he's talking to Jarvis and using the user interface of his battlesuit. Other examples include the idea of contact lenses with screens on them that project displays, holograms, and brain-computer interfaces. Finally, TUI, or tangible user interface, is when data is influenced by interacting with the physical world. For example, tracking your daily steps with a Fitbit, or when you're using gestures with your hand to control something instead of a remote control. For example, the Finch ring is just a ring that you use and you got to move it around and make gestures in order to control things like you would in virtual reality with a controller. Like I said, the Fitbit is also a good example. Another thing to consider is color. White is a common color for text, icons, and guides. Vignettes or gradients in the header and footer can make fixed elements easier to read. People often avoid using too many brand colors when in camera view, Consider using system colors like red, green, and yellow outside of brand colors to convey errors, warnings, or that a process is finished. Try reserving brand colors for call to action buttons or features such as triggers that may be obscured by the user's hand. Another thing to consider is position of your UI elements. To give the user a clear focus of the center of the camera, consider placing fixed elements either at the top or bottom of the screen. Consider placing UI elements that don't show us content close to the bottom. Text in AR apps is usually used for captions or labels. Sans serif is a good font that's usually used because it's often easy to read. Consider using white or yellow when placing text over the camera view. Consider including an opaque or semi-opaque container to make text easier to read. If you don't use a container, consider using soft shadows. Icons. Icons can be detailed, filled, or outlined. Detailed icons often have containers to distinguish them from the camera feed in the background. Icons are used sparingly. Icons often have outlines or shadows to help them stand out on screen. Indicators are another thing to think about, especially for AR apps. They can be detailed or simple. Most often, they are white, yellow, blue, or a low opacity black. They happen to be dynamic and adjust accordingly. They are usually not persistent and disappear or change when an action has taken place. All right, thank you so much. I hope these tips help you. Have a great time developing your augmented reality apps.
From all your friends at the GimWorks studio.
Bye.
Bye-bye.